Hello, Math 1030. This is our last lesson, 12D, and the topic is gerrymandering. So last time we talked about apportionment. Apportionment is the process that's used to determine the number of representatives that each state gets when the House of Representatives is reapportioned every 10 years. In states that have more than one seat in the House, the seats are divided among congressional districts within each state, with the goal of having an approximately equal number of people in each district within each state. But each state has their own rules for how the redistricting occurs. Utah has four districts and recently passed a proposition that calls for an independent redistricting commission to review boundaries. So that's, I think, a good thing for Utah. Every 10 years after the census, the district boundaries have to be redrawn to reflect the shifts in population, because again, you're trying to keep each district with an equal number of people. So if one part of the state is growing faster than another, then the boundaries are going to have to shift a little bit to equal out the populations in each district. So that process is called redistricting. And it's actually a very politically contentious issue. It's become more contentious in the last few years, but like in my lifetime, I've seen it get even more and more contentious. Definitely there is evidence that redistricting is causing problems in our democracy. A lot of the really divided and contentious, fights against Republican and Democrats are kind of coming about in part because of gerrymandering. So here's some information on some elections from 1992 to 2008. So what you can observe if you look at voting histories is that the presidential vote margin of victory is typically very, very small. Our country is really pretty evenly divided among more conservative and more liberal thinking. However, if you look at voting margins of victory for House of Representatives, it is typically huge, between 30 and 40%. So even though the presidential vote, in other words, the breakup of our whole country, is pretty close, in the House of Representatives, it is not close. And the reason for that is gerrymandering. So because of gerrymandering, because of how the districting occurs, the House seats relatively rarely change party affiliation. So like once you've got a Republican in place in that district, once you have district boundaries that sort of favor Republican, it will typically not change seats. Only about 3 to 4% of the time. In 2004, about 10% of House seats changed parties, but typically it's closer to 3 or 4%. So gerrymandering is this practice of redrawing district boundaries for political advantage. And so that term gerrymandering, it came from in 1812, a Massachusetts governor named, whose last name was Gerry, Elbridge Gerry. He created a district, and critics were really upset and ridiculing him, and they said it had the shape of a salamander, which they thought was pretty ridiculous. So we've got gerrymandering. So that's where the word comes from. So gerrymandering, again, it's just the drawing of district boundaries so as to serve the political interests of the politicians in charge of the drawing process. Okay, so we're going to go through and look a little bit closely at Pennsylvania. In the early 2000s, Pennsylvania had 19 seats in the House of Representatives, but after the 2010 census and reapportionment, it actually lost a seat, and it currently has only 18 seats. The districts for those 18 seats are shown in this map of Pennsylvania over here. So you can see there's some pretty ridiculous boundaries. District 12 is one that kind of stands out to me. Whoops, 14 kind of goes quite a bit into it. Another one that looks pretty crazy is 17. So these districts have been drawn by somebody for political advantage. Anyway, so we've got some data on how the voting went in 2010 and in 2012, which was after the redistricting, and we're going to calculate some percentages. So we're going to find the percentage of votes, and then we're going to find the percentage of House seats. So in 2010, our total number of votes, so we've got these votes right here in 2010. So our total number of votes (2034 plus 1882). So we've got 3,916 votes in total. Now these are in thousands, but we can work with these numbers. So if we want to find the percentage of votes cast for Republican candidates, we would just take the total for the Republican candidates, 2034, and divide it by the total number of votes. 2,034 divided by 3,916 gives us, and this is a percentage in decimal form, and we want to round to the nearest one decimal place. So we're going to report that percentage as 51.9%. Now to find the percentage for Democrats, we can do that same thing, divide 1882 divided by 3,916, or I'll show you two ways. 3,916, that gives us 48.1. Or you might notice, oh, they have to add up to 100% in this case, because we're neglecting other parties. So there probably really were some, independent or other party votes, but we're just keeping it simple. So you could just do 100% and then subtract the 51.9% to get that 48.1. So either way you like. So that's in 2010. And I'm going to go ahead and keep with my 2010 numbers for a second and find the percentage of House seats. So now we're focusing on the seats portion of the chart. Now in 2010, this was before the reapportionment, so there were 12 plus 7, 19 House seats. So we'll come up with the percentages the same way by doing the part over the total. So we've got 12 Republican seats out of the total of 19. That gives us 63.1%. And for Democrats, that was 7 out of 19. So 36.8. Oh, I should have rounded that to 0.2. Sorry. Watch your rounding, kids. Okay, so now we're going to switch over to those 2012 numbers. But I guess before we do, I would just like to point out, even though the Republicans got 51.9% of the votes, they actually got 63.2% of the House seats. So there's already a disparity there. Okay, switching over to the numbers for 2012. In 2012, the total number of votes, we've got 2710 and 2794. So that's a total of 5,504. Okay, so if we calculate the percentage for Republicans and Democrats, 2710 divided by 5,504 is 49.2. And then for Democrats, 2794 divided by 5,504 is 50.8. Okay, so now thinking about the House seats, after the reapportionment, the total number of House seats is now 18. So we'll use that to divide. So for Republicans, they have 13 out of the 18 seats. So that's 72.2%. And then for Democrats, they have 5 out of the 18 seats. So 27.8. Okay, so interesting things happened here. So if you look at the percentage of Republicans, it actually went down. It was 51.9%, and now it's only 47.2%. However, the amount of seats they got went up by almost 10%. So they have less voters now, but they now have more representation in the House. So this is the problem of gerrymandering. So if we talk about the distribution of votes here, the distribution of votes compared to House seats. So the distribution of votes that would be this. It does not match the distribution of House seats. So for example, in 2012, even though Democrats had 50.8% of the votes, they only ended up with 27.8% of the House seats. So that is not matching at all. Did the redistricting affect the distribution of votes and representatives? Yes, for sure. The distribution of votes didn't change a lot. We're talking about, less than a 2% change here, or maybe slightly more than a 2% change, but the distribution of House seats changed a lot. And it changed in a way that is sort of contrary to how the voting changed. Okay. You'll have several of those to do on the homework. I think there were 3 of those. All right, so our second example, consider a state that has 8 House seats. So we've got 8 seats. Total population is 4 million. We're going to assume for this district that 38% were Democrats and 62% are Republican, and that these people are always voting along those party lines. So if the district boundaries were randomly drawn, what would be the most likely distribution? Well, if it was random, then we would expect Democrats to get 38% of the seats, and we would expect Republicans to get 62% of the seats. So thinking about Democrats first, 38% are Democrats. So we take that 38% and we multiply it by the 8 House seats, and that gives us a total of 38% of 8 would be 3 seats. And we're, just rounding to the nearest whole number here. For Republicans, we've got 62%. So we multiply that by 8 to get, and again, we need to round to the nearest whole number so that we would round that to 5 seats. So this is how many seats would be represented by Democrat and Republican. If the districts were most likely randomly drawn, it would match pretty well. So our next part is we need to figure out the maximum number of Republican seats, Republican representatives, and the minimum number of Republican representatives. So this is kind of a tricky process. It basically has 3 steps to it. So I'm going to write out the steps and we'll calculate it. So the first thing we need to do is figure out how many voters in each district. And whoops, each district. Oh, sorry, handwriting. How many voters in each district? Now remember that we have a requirement that the districts are as close as possible in size. So we just take the 4 million voters and we divide them into 8 districts. So 4 million divided by 8 tells us that each district is going to have 500,000. Okay, so that's the first bit of information we need. So now we need to know, in order to win, how many votes do you need? Well, if there are 5,000 votes in a district, you would need half. So half of 500,000 is 250,000 plus 1, right? Because to win, if it was exactly half and half, then it would be a tie. So we need half plus 1, which would be, whoops, I didn't add the 1. 250,001 votes. So figure out half and then add 1 to figure out how many votes to win. Okay, so now we're ready to figure out the maximum number of districts. So thinking about Republicans first. So for the Republicans, we have 62% of our population that identifies as Republican. So to figure out how many Republicans there are, we take that 62% and we multiply it by our 4 million people. So that's 62% of 4 million people. Means that we have 2,480,000 Republicans. So again, that's the percentage multiplied by the total population. So 62% Republican multiplied by 4 million people. So now that we know how many Republicans there are, we have to think about how we can group them. Now we want to group them so that they have just enough to win. You know, we don't want to put 500,000 Republicans into one district together because we don't need that many to win that district. We only need 250,001 Republicans in that district to win it. So what we're going to do to find the maximum number of districts is we're going to take those Republican voters and we're going to divide them into groups that are just big enough to win. So 250,001. So how many groups do we have that are just big enough to win? So we have enough to make 9.9 groups. Well, there are only 8 boundaries, 8 districts here. So Republicans' maximum that they could win is 8. Now, to figure out the minimum number that the Republicans could win, we actually have to think about the Democrats for a minute. So if we think about the Democrats for a minute, so there are 38% Democrats, and if we times that by 4 million people, that gives us 1,520,000 Democrats. So if we think about how many of them we could group into districts that are just enough to win, we would take that 1.52 million and divide it by 250,001. And that gives us 6.07. So we want to round down here, and you actually always want to round down because you don't have enough to win that 7th seat. Even if it was 6.8, we would still round down because we don't have enough to win that last district. So the Democrat max is 6 seats. And that means that the Republicans would have the other 2. Because there's a total of 8 seats. So to figure out the minimum number for Republicans, you have to figure out the maximum number for Democrats. Democrats can win 6 at most, which would leave Republicans with 2. Okay, so that's a little bit tricky. If you're having problems with that one, let me know and I can help you out with that one. Okay, last topic is boundary drawing. So the courts have generally allowed even very convoluted district boundaries to stand, even when they've been challenged in the court system, as long as they don't violate any specific laws, and they do have to meet the following criteria. So districts within a particular state must have pretty nearly equal populations. You can't put tons of people in one district and very few people in another. They have to be close to equal on the populations. And then the other requirement is that districts have to be contiguous, meaning that they have to be connected to every other part. You can't be like this one and 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 this one make a district. They have to be connected. So the best way that to kind of see how gerrymandering can be accomplished is to kind of just draw some sample districts and see how it really does change how the voting would go. So this is a really simplified grouping of 64 voters. And so just depending on how you draw it, you can have a different number of Democratic and Republican seats. So you know, I could draw it to try to keep as many Democrats together as possible. That would favor Republicans. 1, 2, 3, 4, 5, 6, 7, 8. We're going to try to keep it with, 8 groups of 8. So there's 1 seat, and then another one that is all Democratic. And then, let's see, this one. 1, 2, 3, 4, 5, 6, 7, 8. So you have to keep them connected. So I'm trying to avoid having cutting anybody off. 1, 2, 3, 4, 5, 6, 7, 8. So I was able to draw it in a way that, and I'm going to highlight it to show you 1, 2, 3, 4, and then another 4. I'll highlight them. Okay, so by focusing on concentrating the Democrats as much as possible, I have created a situation where I have 1, 2, 3 that would be won by Democrats, and then the other ones, this one would definitely be Republican, 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 and Republican. So we have 5 that have Republican voters. But if your goal was different, if you were a Democrat and you were trying to concentrate it so that there was a majority of districts that were being represented by a Republican, you absolutely could do that as well. You would just sort of have a different goal in mind when you drew it. So I have on this next page 6 different districtings. So if you were a politician in charge of drawing and you wanted Republicans to win the majority, you absolutely could. You could have them win as many as 6 in this case, just depending on how you draw. And you can see like these first couple are drawn in what maybe would be a pretty reasonable way, but the last one is really carved out, in bizarre shapes. But if you were a politician who favored Democrats, you could absolutely draw the districts in order to favor Democrats, just drawn differently. So whoever's in charge, they have oftentimes the ability to affect these boundaries, and they can draw it in order to favor themselves. And so this just gets worse and worse over time because if you have Republicans in charge, they're going to draw it to favor Republicans, and then it's very hard to ever change it. And they can keep redrawing it in order to help their party as much as they can. So that's why independent districting committees are really important and can really help keep our democracy in balance and that it's more representative of the actual people. So I think you'll have one, I think, where you have to maybe multiple choice select boundary drawing. So this one says, suppose the states at the right has 4 districts with 4 voters in each district. We want to try to find a way to draw the boundaries so that one district is all Republican, which would leave Democrats with either a majority or a tie in the other 3 districts. So districts have to be contiguous. They have to be connected. So if we wanted to try to find a way to draw this so that the districts were connected, we can't. So for example, we couldn't do this because these 2 blue Democratic houses are sort of isolated and can't be connected. We can't like loop outside the box, okay? So that would not work. It's still possible to draw it so that the districts are contiguous. So if we group these Republicans together, we have a group over here that favors Democrats. We have a group over here that favors Democrats, and then we have these 4 together. So this gives us 1 Republican district, 2 Democratic districts, and 1 tie district. So even though this population is 50-50, we were able to draw districts so that we have 25% Republican, 50% Democrat, and 25% tie. So you know how you draw your districts really can affect what sort of political representation your state gets, and that is gerrymandering. So let me know what homework questions come up. The two sections from 12C and 12D, they are not going to be on your final. The ones from 11 will be. I'll send out an updated final study guide, but finals coming up, and after that, no more math to worry about for the year. So that is good news. Let me know what questions come up. Thanks.